This is Geometry B, Unit 3, Lesson 3. We're going to prove triangles similar. I want to start by reminding us of the triangle congruence postulates that we learned. Remember, for triangles to be congruent, all sides must be congruent and all angles must be congruent. Okay? But we learned some shortcuts last semester. We learned side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. That if all three sides of a triangle are congruent, then the triangles are congruent. We don't need to prove all the angles are because they simply will be. If two sides are congruent, and the included angle between them are congruent, then the triangles are congruent, and so on and so forth. So all these shortcuts that we learned. For similarity, the contrast is this. For similarity, all sides aren't congruent. All sides are proportional. Proportional. And all angles will be congruent. But it's not necessary to prove all sides are proportional and all angles are congruent. Just like with congruence, there are shortcuts. There is the side, side, side similarity postulate. So indicate side, side, side with a tilde for similar. If three sides are proportional, then the triangles are similar. Same with this, side, angle, side similarity. If two sides are proportional and the included angles are congruent, side, angle, side works. Now there's no reason to do angle, angle, side because angle, angle is sufficient. If two angles are congruent, then the third angle is going to be congruent because they must add to 180. And angle, angle is sufficient. And angle, angle covers angle, side, angle, 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 side as well. Okay, and we don't generally deal with the hypotenuse leg thing for similar polygons, but we could, but this unit does not. So these are the triangle similarity postulates. Now let's practice using them. Okay, so I'm going to go to a new slide here, and we're going to do a triangle similarity proof. So here's the situation here. I've got two triangles, and they are going to be different sizes, right? Different sizes. But they're going to be hopefully similar here. So here we go. This is a fairly common scenario or situation. Do you remember when doing triangle proofs, one of the things you want to look for is shared sides. If you have a shared side, then you can use the reflexive property, or vertical angles. And here we have vertical angles, so that's going to come in play. Vertical angles are opposite angles formed by intersecting lines. They share a vertex, but they do not share a side. Okay? So here we go. We have A, B, C, D, and E. Okay? And let's say we know that AB is parallel to DC. Okay? So the given is the drawing, of course, and the fact that AB is parallel to DC. AB is parallel to DC. And we want to prove the triangles are similar. So prove triangle ABE, like Abe Lincoln, right? ABE is similar to, and we've got to match this up. It's going to be similar by rotation. So A goes with C to CDE. So ABE is similar to triangle CDE. Okay. So as with any good proof, we want to start with the given. So AB is parallel to DC. And the reason I know that they're parallel is we were told they were so. So the reason is given. Okay. Statement 2. Well, I'm going to forego statement 2 for now, actually, and I'm going to jump to the end. Where do we want to end? What are we trying to prove? We're trying to prove triangle ABE is similar to triangle CDE. And the reason for it, I don't know yet. It's going to be one of these. It's going to be side, 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 angle, or angle, angle, because those are our similarity postulates. So it's going to be one of those, but we'll figure that out later. All right, so let's see where we can go. One of the things that occurs to me, actually, we already mentioned it briefly, is that these share a vertex E. Okay, and with this shared vertex, there is a pair of vertical angles. Okay, so let's say this. Angle CED is congruent to angle CED. Make sure they match up. AEB, right, by rotation. CED is congruent to angle AEB. How do we know they're congruent? Because vertical angles are congruent. That's known as the vertical angle theorem. Vertical angle theorem. Okay? So we've got a pair of angles congruent. Okay? So that would be good for side or angle angle. I think we don't know anything about sides. I think we're going to need to go for angle angle. So what I need is one more pair of angles congruent. Now I'm going to pick on this fact. I have DC parallel to AB and I've got a transversal. We call these two angles alternate interior angles. And when lines are parallel, which they are, alternate interior angles are congruent. So here's what I'm going to say. I'm going to say angle DCE is congruent to angle BAE. So step 3, angle DCE is congruent to angle BAE. How do I know? Because alternate interior angles are congruent when lines are parallel. This is known as the alternate interior angle theorem, using abbreviations. Alternate interior angle theorem. And now we've got it, I think. I think we've got it. We've got an angle congruent to an angle. We've got an angle congruent to an angle. So I've got two pairs of congruent angles. That satisfies the angle-angle similarity postulate, which says, step 4, the triangles are similar by the angle-angle similarity postulate. Don't forget the tilde after to indicate this is the similarity postulate, not the congruence postulate. Okay, so that's it. That's an example of a proof that two triangles are similar using angle-angle. And you can do other proofs using side, 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 or side, angle, side as well. All right, hopefully that helps.